Welcome to lesson 4.4. If you recall in the last lesson, we started with a bunch of equations, and I gave you some time to brainstorm how you would solve this, and then to come back and see how you solved it worked. We're going to do the same thing for the start of this lesson, except we're going to focus more on logarithmic equations instead of exponential. So we're going to start with this one right here. I'm going to give you about 10-ish seconds to brainstorm. Pause the video if you need more time. To brainstorm how you would start this problem. Try it out, see if it works, and then you can come back and we'll do it together to check and see how you did. Okay. Now, the first thing I would notice about this problem is that this is already my one-to-one logarithmic property. ln is log base e, ln is log base e. If I have logarithms of the same base, I can just set the insides equal to each other. And solve. Bring everything to one side. Factor. And solve. And now we have some answers. Now, one thing we didn't have to worry about last time was checking those answers. And that was because we were solving exponential equations. However, if you notice in this one very quickly, I am solving logs, which means I need to plug my answers back in and see if they work. Now, plugging them back in and seeing if they work, what I mean by that is to plug them back in and make sure that you don't get a negative inside the logarithm. So I plugged my 3 back into my original equation, and let's see what we get. This becomes 9 minus 9 minus 1, which is a negative 1. And right away I should go, hey, that doesn't work. We can't put a negative inside a logarithm. It's not part of the domain. It doesn't work. If you forgot about it, think of the graph of log. It doesn't hit negative 1 over there. It doesn't go over to negative 1. So I cannot have a negative inside a logarithm. So right away, 3 does not work. Let's try negative 1. So this gives me 1 plus 3 minus 1 is a 3. So far, so good. Both of those are positive numbers, so negative 1 does work. So don't forget that if you start with a logarithmic equation, you do need to check those answers by plugging them back in and make sure you're not plugging in negatives. Let's try the next one. Take a few seconds real quick. Pause the video, brainstorm what you think you should try to do with this one, and then we'll come back together and talk about it. Now, this one you could actually start 2 different ways. In the first way, you could recognize that 1, this one right here, is the same thing as log base 3 of 3. If you remember your log properties. And now that these two have the same base, I could change their addition right here into multiplying. 3 times x minus 4. And now I have logs of the same base, 1 log on each side, so that's my one-to-one property. So I can just set the insides equal to each other. Distribute that 3. And I solve from here. Get 16 equals 8x to get x equals 2. Now, we will check that answer, but before we check it, I also wanted to show you the other way you could solve this. The other way you could solve this is by subtracting this log over to the other side, by bringing the logarithms to the same side. So if I subtract this log over, I would get log base 3 of 4 minus 5x minus log base 3 of x minus 4, because I subtracted that one over, equals 1. And now that I have the logs on the same side, I could turn this subtraction into division. And now that I have a single logarithm, I could change the form. Base stays the same, input and output flip places. And then I can times by x minus 4 to get it out of the denominator. And you'll see if I distribute that 3, I end up at the same place I did right there. So those are two totally different ways to solve the exact same problem. Both of them work, both of them get to the same answer. Now let's check if our answer is even right. Let's plug the 2 back in, make sure that it's a positive answer inside the log. That's a 1. There we go. So if I simplify this, I get 4 minus 10, which is a negative 6. And right away I go, nope, can't put a negative into a log, so this answer does not work. So my actual answer is no solution, or DNE. So that was our first 2 examples. Let's do one more example and then we'll wrap up this video. So once again, take a few seconds to brainstorm what you could do with this problem, and then we'll do it together. Okay, the first thing I see when I look at this problem is I'm adding some logs here, which means I could change those logs to multiplying if I'm adding them. Now I have a single logarithm here, which means I can change the form. So this is log base 10. 10 to the first equals this. So this is still just a 10. I can distribute those to get 5x minus x squared plus 10 minus 2x, which is negative x squared plus 3x plus 10. Bring everything to the same side. And I end up with that. Now I notice they have an x in common, so I'm just going to take a negative x out and then set them both equal to 0. So I have x equals 0 and x equals 3. And now I just need to check my answers. So let's plug in 0 first. So that becomes log of 2 plus log of 5 equals 1. Those are both positive, so 0 works. Now let's plug in 3. So that's log of 5 plus log of 2. Those are also both positive, so 3 also works. So in this case, both answers actually work. So that was some practice solving logarithmic equations by looking at them and knowing what to do first. In the next video, we'll talk about a logarithmic story problem and solving a logarithmic problem that's a little more complicated.